Okay, so this is the extra credit that was offered on the back that not a lot of people tried, but the people that actually tried it realized that it was a lot easier than the other one for the test. So if they actually would have done this first, or if they would have just done what they'd known and then skipped to the extra credit problem, they would have probably gotten enough points to do well on the test anyways, if they knew what they were doing. So again, same as the last problem, we're going to start with figuring out, is this thing even solvable or not? So is it statically determinate? So the formula for that is 2j equals m plus r, which is 2 times the number of joints equals the number of members plus the number of reaction forces. I didn't label the joints in this case. Joint is going to be B, this one's going to be labeled C, and then the other one's going to be labeled A. So there are my 3 joints. You have to look at the reaction forces now. So it's really a matter of you looking at these supports and figuring out, okay, which way do I think they're going to be going. I'm going to be making this the reaction force RC with respect to Y going perpendicular or normal to the surface of a roller support, because it's always going to be just one reaction force in that case. So I'm going to make it go down. I'm going to be making, I see that there's a force going to the right. There's going to be a pin support here, which has 2 reaction forces. Therefore, I'm going to make this one go opposite to that, which is going to be to the left. So this is going to be RBX. I'm going to make a reaction force here at B, because remember, pin supports have 2 of them. I'm going to call this RBY. Why did I make it go up instead of down? Well, since I already have one going down here, RCY, I'm going to have to make this one go the opposite direction. Once you guys do more trusses, you'll realize that everything is going to eventually balance out. So I kind of just went by this guy. This is going down, so this is going to be going up. Again, don't stress too much about it. If you guys just make them both go down or make them both go up, your math will actually work out in the end, and it'll actually tell you that you did something wrong and which one needs to be switched at the end. So let's start from there. So 2j equals m plus r. So 2 times the number of joints, which happens to be in this case 3. So A, B, C, right? 3 of them. Equals the number of members, which again, 1, 2, 3. Think of the poles. Plus the number of reaction forces, 1, 2, 3. So RBX, RBY, RCY. The reaction forces are the forces that you drew in based on the supports. So we get 6 equals 6, which means we can solve this problem. Done. So now let's move on to the next step. So let's figure out what is the reaction forces. Again, my recommendation is start with the pin, take the moments about the pin. So in this case, we're going to start with this one, take the moments about this one. We got to figure out the distance here, which the problem actually gives us already. This is going to be 7 from the extra credit, and this is going to be 6. This was labeled for you. So let's take the moments about B. So the very first thing I'm going to do is take the sum of the moments about B. Why B? Again, because there's a pin support there. If I take the moments about here, I eliminate 2 reaction forces, and I only got 1 to solve for. So this is going to be first this distance, which is 7, multiplied by this force, which is going to be RCY. Since I'm going in this direction, this is going to be in the negative angle direction, so it's going to be a negative. So it's going to be negative 7 RCY. Now, the only other force that's acting on this distance away is going to be the 350 pounds of force. There's going to be 3 multiplied by 350, which is going to be in the positive angle direction. So that's going to be a plus. So plus 3 multiplied by, 6 multiplied by 350. Set that equal to 0. Again, there's no other reaction forces because the ones that I blocked right there at pin B, don't count on it because they're acting right on the pin. That's why first step, if you guys start at the pin, taking the moments, you should be fine. So negative 7 RCY. If I multiply these two, I get 2100. So plus 2100 is equal to 0. So RCY is equal to 2100 divided by 7, which means that RCY is equal to 300 pounds of force. So there we go. RCY is equal to 300 pounds. We have one unknown so far. We got to figure out the other 2 reaction forces. So it's positive, meaning that our initial assumption that the RCY was going up, or sorry, down, is actually correct. So the direction actually is correct because we have a positive answer. So if we keep moving, this time we're gonna, because some of the moments it's good to use, but it's a little harder than the sum of the forces. So let's do sum of the forces. It's a little easier to see. Sum of the forces in the x directions, set that equal to 0. The only forces that we're acting on the x direction is the 350 pounds and the negative RBX, right? So it's going to be negative RBX, and it's negative because it's going to the left. Positive 350, and it's positive because it's going to the right, equals 0. If you solve this, you know that RBX is equal to just 350. And it's going to be a positive answer, meaning that your assumption was correct for the direction. So RBX equals 350 pounds of force in pounds. I forgot the pounds, but... All right, so all we got to do now is solve for RBY. Again, same idea. We can use the sum of the forces in the y direction. So Fy equals 0. In this case, the only thing we have in the y direction is RBY. Where is it? Where is it? Yeah, RBY. So RBY minus RCY equals 0. The only forces that are going up and down are this guy and that guy, right? So since you already know RCY from back here, you could just say that RBY minus 300 equals 0. And if you solve that, you know that RBY is equal to 300 pounds. Okay, so we have our reaction forces solved for already. Typically, I like to just redraw this to not get myself confused with the RB and RC and all that other stuff. So I'm just going to redraw this truss, so this triangle. I'm going to just eliminate the names. I'm going to put just the reaction forces acting on the joints. So the reaction force, that one's going down, this one was going up, this one was going to the left, this one was going to the right. This is the load of 350 pounds. And then the reaction forces that we just figured out, RBY was going to be 300. This one was also going to be 300 going down. This one's going to be 350 going to the left. So I just kind of replaced everything that I solved for here in the diagram, so I don't have to get confused about that later on because there's too many things going on, too many variables. So some of the forces in, so let's do the method of joints. So it doesn't really matter which one you guys pick, since no matter which one you pick, there's only 2 members on it. So I usually, go by that. Doesn't really matter which one you pick. So just label your angle of appreciation in this case, the 40.601. In this case, I'm just going to go ahead and just make an executive decision and say, we're going to do the calculations at joint C. Just a matter of choice. So if we look at joint C, so there's my joint. There is a 300-pound force acting down on it. Then you have member CB, which we're going to just assume that is going to be in tension. And then we're going to have member CA that we're going to assume that is going to be in tension. And then the angle that is there is the 40.601. All right, so some of the forces in the y direction, some of the forces in the x direction. Again, stop and think about it. Which one do you think is better to do first? We have our unknown already in the y direction, so let's do the one in the y direction so we can figure something out. If we do the ones in the x direction, we have nothing that we actually know, so we can't figure it out. So first, let's do the sum of the forces in the y direction, set that equal to 0. So we can actually solve for something. So this one's going down, so it's going to be negative 300 pounds of force, and then this one's also going down, so it's going to be negative CA multiplied by the sine, again because we're looking at the y component, of 40.601, and then set that equal to 0. If we solve this, we get that member CA is going to be negative 300 divided by sine of 40.601, which means that when we pop that into the calculator, we get this is going to be negative 460.98, give or take, in compression. So it is in compression, meaning that, hey, my drawing is actually wrong. So I got to go back to fix that drawing. So the drawing, the arrow should actually not be in tension. It shouldn't be going out. It should actually be going towards the joint, which is very important because when you actually have the next calculation, this is going to come into play. So I fixed it. It should actually be in compression. Now, if I want to solve for anything else, I need to take that into consideration. So let's do the sum of the forces in the x direction now. So sum of the forces in the x direction, set that equal to 0. In this case, the only thing we have in the x direction is the member CB. So that's going to be in the negative direction because it's going to the left, and CA cosine of that angle. So we're going to have the forces as CA cosine of the 40.601 minus CB, which is going to the left, is equal to 0. So since we already have CA is negative 460.98 in compression, you could actually use that value to solve for your other member force, which again was the real reason why we started with the sum of the forces in the y direction. So we're going to plug that in now. So it's going to be the 460.98 multiplied by the cosine of 40.601 minus CB equals 0. Again, I did not include the negative for the CA, even though it says CA is negative 460.98 in compression. That negative sign just has to do with the direction of the vector. So since I already flipped it, I switched it around. This kind of accounts for the negative sign already. So you just kind of go by the arrow, and then everything else just it's in the past. If I solve for this, I get that CB is going to be 350 pounds in tension. Tension meaning that it's positive. And we are actually almost done because this only has 3 members and we already solved for 2, which is 1 calculation. So if you go back to the original drawing, CA, that's this member from there to there. CB, that's this member from there to there. So we have 2 out of 3 done. We just got to solve for another one. So pick another joint. Doesn't really matter which one. I'm going to be picking joint A. So let's do joint A. And I'm going to just do the calculation somewhere else to not confuse anyone. So calculations of joint A. So the calculations of joint A are that. So we have the 350 pounds of force going towards the joint. We have one going vertically, which is the member we don't know. This is member AB. And we have member AC that is, if you guys remember, AC was supposed to be in compression, or CA is supposed to be in compression, so this was going to be going inwards. So CA, or AC, is in compression. I'm going to, since I started A, now I'm calling it AC, but we're talking about the exact same joint. We're talking about this one. All right, so let's have the sum of the forces in the X or Y direction equal to 0. But hey, the one that I actually don't know, because I know AC, right? AC is going to be the 460.98. We know that already. We know this already. Let's do the sum of the forces in the Y direction, because this one's only you can only see it in the Y direction. So we can figure out the last unknown. So set that equal to 0. So the only thing we have is AB, which is positive because it's going up. And then we're going to subtract AC. So it's going to be minus AC sine of this angle. So minus AC sine of the 40.601, which I did not label anywhere, but it should be here. So this angle right here is 40.601. Again, we get that from the drawing. So we have this angle, which is the same as this angle by alternate interior angle theorem from geometry. So AC sine of 40.601 equals 0. If we solve this, we get that, or actually, we should probably plug in the AC. So 460.98 sine of 40.601 equals 0. Solve that, you get this number. You get, it's actually supposed to be 300. So AB is equal to 300 pounds. Since it's positive, we're going to say that it's going to be in tension. There we go. We have all of our unknown members. These problems can get tricky sometimes because one single negative answer, one single wrong answer can just have a domino effect and just mess up the rest of the answers if you keep using those values. So I understand why, some people might have trouble with this, but hopefully this video helps. So see you guys later.